Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What are user-defined data types and when should you go for them? User-defined data types (UDTs) allow you to create custom data types in SQL that are based on existing primitive or built-in types. They enable you to define your own data structures with specific characteristics and constraints, making the data model more expressive and tailored to your application's needs. Here are some scenarios where you might consider using UDTs. 1. Data abstraction. UDTs provide a way to abstract complex data structures and define them as a single data type. For example, if your application deals with geographical coordinates, you can create a UDT called coordinate that combines latitude and longitude attributes into a single data type. This abstraction simplifies the handling of coordinates throughout your application. 2. Data integrity and consistency. UDTs allow you to enforce specific rules and constraints on data values. By encapsulating these rules within the UDT definition, you can ensure consistent and valid data throughout the database. For instance, you can create a UDT called a mail address that enforces a specific format and validation rules for email addresses, preventing the storage of invalid or inconsistent email data. 3. Code reusability and maintainability. UDTs promote code reusability and modularity. Once defined, UDTs can be used across multiple tables, columns, and procedures in your database schema. This eliminates the need to repeat the same data type definition in multiple places, improving code maintainability and reducing the chances of inconsistencies or errors. 4. Domain-specific data modeling. If your application operates in a specific domain or industry, UDTs can be used to model domain-specific concepts. For example, in a healthcare application, you might create UDTs for patient, diagnosis code, or medication to represent the unique identifiers or specialized data types used in the healthcare domain. This enhances the clarity and comprehensibility of your data model. 5. Data presentation and semantics. UDTs can help improve the presentation and semantics of data. By defining meaningful names for UDTs, you can enhance the understanding of the data structure and its purpose. For instance, creating a UDT called phone number provides a clearer indication of the data's purpose compared to a generic VACHA column. 6. Ease of maintenance. UDTs can simplify maintenance by centralizing data type definitions. If a change is required in the structure or validation rules of a specific data type, modifying the UDT definition will automatically update all associated columns and instances of that UDT in the database. This reduces the effort and potential errors associated with manual updates. 2. How do you implement one-to-one, one-to-many, and many-to-many relationships while designing tables? 1. One-to-one relationship. Approach 1. Place the related attributes in the same table. This approach works when the related attributes are few and directly associated with the primary key of the table. For example, if you have a person table with an attribute called address, you can include the address attribute as part of the person table. Approach 2. Create separate tables for each entity and establish a primary key foreign key relationship between them. For example, you can have a person table with a primary key column and an address table with a foreign key column that references the primary key of the person table. 2. One-to-many relationship. Approach 1. Place the foreign key in the many-side table. For example, if you have a department table and an employee table, you can include a foreign key column in the employee table that references the primary key of the department table. Approach 2. Use an intermediate table to establish the relationship. This approach is useful when you have additional attributes related to the association between the entities. For example, if you have a student table and a course table, you can create a third table called enrollment with foreign key columns referencing the primary keys of the student and course tables, along with additional attributes such as enrollment date. 3. Many-to-many relationship. Create an intermediate table, also known as a junction or associative table, that represents the relationship between the two entities. This table contains foreign key columns that reference the primary keys of both entities. For example, if you have a student table and a course table, you can create a student course table with foreign key columns referencing the primary keys of the student and course tables. Each row in the student course table represents a specific student enrolled in a specific course. 3. What is bit data type and what's the information that can be stored inside a bit column? In SQL, the bit data type represents a binary value that can store either a 0 or a 1. It is commonly used to represent Boolean or logical values where a true/false or on/off state needs to be stored. The bit data type in SQL typically occupies 1 byte of storage, although it may vary depending on the database system. In most database systems, the bit data type is implemented as a single binary digit, allowing it to hold either a 0 or a 1. Some database systems, like SQL Server, also provide the ability to represent an UL value in a bit column. A bit column can store various types of information, such as 1. Boolean values. The most common use of the bit data type is to represent Boolean values, where 0 typically represents false or off, and 1 represents true or on. For example, a bit column named isActive can indicate whether a certain condition is active or not. 2. Flag values. Bit columns are often used as flags to indicate the presence or absence of a certain attribute or feature. For example, a bit column named isDeleted can indicate whether a record has been marked as deleted or not. 3. Switches or options. Bit columns can be used to store switches or options that can be toggled on or off. For example, a bit column name has permission can indicate whether a user has a specific permission or not. 4. State indicators. Bit columns can be used to represent the state of an object or process. For instance, a bit column named isCompleted can indicate whether a task or process has been completed or not. 4. Define candidate key, alternate key, and composite key. 1. Candidate key. A candidate key is a minimal set of one or more attributes columns that can uniquely identify each record row in a table. It means that no two records can have the same combination of values for the candidate key attributes. A table can have multiple candidate keys, and each candidate key is capable of uniquely identifying records. However, one of the candidate keys is typically chosen as the primary key. The primary key is the candidate key selected to uniquely identify records and enforce entity integrity. The other candidate keys are called alternate keys. 2. Alternate key. An alternate key, also known as a secondary key, is one of the candidate keys that is not chosen as the primary key. While the primary key uniquely identifies each record in a table, alternate keys can also provide uniqueness but are not designated as the primary means of identifying records. Alternate keys can be used for other purposes, such as enforcing uniqueness constraints on specific attributes. For example, in a table of employees, the Social Security number SSN could be an alternate key if another attribute, such as an auto-incrementing ID, is chosen as the primary key. 3. Composite key. A composite key, also known as a compound key, is a key that consists of two or more attributes columns working together to uniquely identify each record in a table. Unlike a single column key, which uses only one attribute, a composite key combines multiple attributes to form a unique identifier. The combination of these attributes must be unique for each record in the table. For example, in a table of students, a composite key could consist of the combination of the student's ID and the semester, ensuring that each student can be uniquely identified within a specific semester. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.